All right, this is a lecture covering Chapter 7 of Keith Stanovich's How to Think Straight About Psychology. In chapters 1 through 6, we get a lot of research design or experimental design information. And then in the latter chapters, there's more of a focus on why the criticisms of experimental design don't stand or can be refuted. So, in other words, chapters 1 through 6 look at how to experiment in psychology or how to design studies that are sound within the logical empirical framework of psychology. And then the latter chapters focus more on what some of the criticisms of that style of research are in psychology. Now, I differ with Professor Stanovich on many of the arguments that he makes, but I want to appreciate the arguments, his position, the defenses he provides, but also consider the bigger context and the bigger field of psychology. So one of the criticisms of an experimental approach to psychology is that the emphasis is often on artificiality. So I think one of the examples I've given frequently in these little lectures has been a psychologist who's interested in studying the learning of, say, kindergartners. So if we want to understand, let's say, social learning in kindergartners, so these are very young children who have spent most of their time with their immediate family members, and they've been socialized to interact with parents and possibly siblings, maybe cousins, and neighbors if they have a lively and active social life. Now, a big part of elementary school or kindergarten is becoming socialized with people your same age, and so that's a really important goal of kindergarten. So how does that happen? How does it work? If we were interested in studying kindergartners' socialization, arguably we would have to go to these classrooms and watch it happen firsthand. If we wanted to test hypotheses about the fastest way to socialize children or the best way to socialize children or possibly harmful ways of socializing children, they would need to take place in those naturally occurring classrooms. And we couldn't test them in artificial ways. We couldn't introduce a character, a person who has no place in a kindergarten. It would have to be real things that may happen in kindergarten. And so the criticism that Stanovich argues against is that creating an artificial context, so designing your own kindergarten classroom where you can control all of the variables to make sure that what you're testing, or that you're only testing one variable and not multiple confounding variables, is to create this artificial classroom. But once we do that, we're no longer looking at kindergartners in their natural environment. We're creating a superficial or an artificial one. Therefore, the findings don't follow, or we can't generalize those findings to actual classrooms. So that's the criticism that Stanovich is trying to defend against. Now, this happens to be a criticism of experimental psychology that I think is very important to understand. So I will present the other perspective throughout this lecture. Okay. The first argument that Stanovich makes in defense of artificiality is that it's not a weakness, it's a strength. Now, in order to understand why artificiality is a strength, you have to appreciate the goal of experimental science. And the goal of experimental science is to create conditions where you can test one variable and then control all other variables. That way, you can say with confidence that this variable, let's say it's, for the kindergarten circumstance, let's say it's children are more likely to become socialized when they're surrounded by small groups of peers, and we can define small groups as 5 or fewer. That once you get to 10 or more, it becomes intimidating, and so that could be scary to try to socialize with 10 or more people, but as long as the number is 5 or less, then it's like a safe number. And so the independent variable is the size of the social group. If I was interested in testing the size of the social group, then I would need to control that one variable so that there would be a large group and a small group, and I could compare the socialization between those two without having to worry about which school they're attending, how much recess they get, how kind their kindergarten teacher is, or how horrible and awful the kindergarten teacher is, what they're eating for lunch. Like, all of those things could potentially influence how the socialization occurs, how much sugar they've had, how long their nap time was. All of these are possibly confounding variables that we would need to control. Therefore, but they all happen in a natural kindergarten classroom. So if we want to control all the variables and only test the one variable, which is the size of the social group, we need to create artificial conditions where we have that control. Therefore, for Stanovich, artificiality doesn't mean we never get to examine the social life of kindergartners. It means that we have the capacity to create conditions where we can test and isolate and test individual variables. And so for Stanovich, that's a good thing. So I wrote this down as like a possible critique. So what a critic of experimental psychology, educational psychology in particular, might say: if I want to study college student in-class behavior, then I have to witness college students who are actually in class, right? Well, and the argument would be no. Within the scientific reasoning model, artificial conditions allow a researcher to approximate natural condition and control variables when they're the variables they're not interested in studying. So yes, in an experiment, particularly in a laboratory, I'm actually sitting in an office that used to be a rat laboratory a few decades ago. While laboratory conditions are not natural, they do allow the researcher, the scientist, the experimental psychologist, to control all possible variables. So there's no confusion over what variable is responsible for the effect that's later measured. Now, I mentioned telling both sides of the story. The other side of the story, which argues that artificial conditions are artificial and we should suspend the assumptions of modern science when interpreting the results of artificial research conditions. The critique there is that if I'm studying kindergartner behavior, but I've put them in a bizarre environment, an environment where there's only one independent variable that's acting on them, we can't expect to learn anything about actual kindergartners who live in these complex social environments where there are a lot of factors that are all competing for their interest and competing for impact on them socially. That would be a closer, even though it's messy, so we don't know which variables are responsible or how responsible they are, it's messier. However, life is messy. So like the linear model that's promised by experimental psychology is not representative of the sort of factors that impact social behavior in this example, or learning behavior, social learning behavior. So when we create artificial conditions in psychology, I think there's a good criticism that while we can understand the influence of single variables, it's very rare that single variables are responsible for the outcomes that we measure. It's a rather simplistic way of looking at something that is infinitely complex, such as human behavior, human mind, motivation, emotion, and so on. And so I personally, in my research, am more interested in the complex, albeit convoluted and confusing and uncertain environment that is the human environment, or the way that we derive meaning from experience, which doesn't always follow logical, linear paths. So again, Stanovich's position is that artificiality is a strength. I happen to agree with the criticism that artificiality is a weakness. However, I do not espouse the logical, empirical framework that Stanovich is drawing on. And in order to be an experimental scientist, you have to first adhere to the assumptions of logical empiricism. Again, that information that we have has to be empirical, so it has to be based on our observations. I'm a fan of that. and that those observations have to be logically related, and so they have to follow the principles of Aristotelian logic. That I disagree with. However, that's the way that modern science, that's the method that modern science has adopted. And if you want to work within that structure, in that metaphysical structure, you have to at least accept temporarily those rules of logical empiricism. So that's why I put this only applies within the philosophy of logical empiricism right here. Boom. Okay. Stanovich goes on to describe two types of research, and I think this is a really important distinction. Throughout the book so far, he is focused on applied research, and so this is the hypothesis testing that's been described throughout the book. So if I wanted to, like in my classroom, I wanted to test whether or not this workbook that I'm describing through these lectures helped students achieve the learning objective of applying scientific reasoning to matters of psychology, sociology, criminal justice, and so on, the social sciences, I could design a study where I test it. Maybe in one group, I use the workbook, and in another group, another class, I don't use the workbook, and I do everything else the exact same. One has a workbook, one doesn't, and then I test achievement at the end. What I'm doing is testing a hypothesis that the workbook will influence achievement of that learning objective, and I have a control group that I can compare the results with, and then I could say with some certainty and probability of accuracy and probability of error, if I measure all of those things, whether or not the workbook is effective. So I have a hypothesis. The hypothesis is testable, and I've designed an experiment to test that hypothesis. Now, if I do so, I need to be pretty careful that the samples that I'm using are random, that students have an equal likelihood of being in the research manual class and the non-research manual class in order to strengthen the likelihood that there isn't some other variable about those participants that can explain why one group was had higher achievement than the other group. So all of that stuff is really important, and we talked about that in chapters like 4, 5, and 6 in particular. But that might make you think that that's the only route that scientists have. But Stanovich gives a good example of what that might look like in entomology, which is the study of insects. If you discovered a new insect species and you just found one, like say one little tiny species of ant that's never been discovered before, it would be worthwhile to just observe that one new species of ant and see what it does, what it eats, how long it lives. All of that would be very valuable empirical data that you could then probably generalize to other examples of that one species. You wouldn't have to say, well, let's say if there's 8,000 of those ants, I can't just look at the first one I see. I need to every one of those 8,000 ants needs to have an equal likelihood of being part of my study. Well, of course, that's not the way that basic research is conducted. It's worthwhile when investigating a phenomenon for the first time to just focus on one and record what you see, and that's valuable. Every subsequent study will be based on those initial observations. The observations will get exceedingly complex, exceedingly nuanced, be focusing on more and more highly nuanced aspects of behavior and nutrition, diet, lifespan, and so on. So basic research can happen in psychology too. We may discover a new theory of motivation, and I give an example here of self-determination theory. For decades and decades, the assumption was you and I are motivated by what goodies we can get. So I study psychology because people have applauded me for it, and I can make lots of money, and I feel good doing it, so that my decisions are always based on some sort of feedback loop. Self-determination theory recognized aspects in which that behavioral study of motivation didn't work. And they found, over a period of 50 years, 3 aspects of motivation that seem to apply to a lot of different demographics worldwide. And those aspects of motivation are highly robust, which means they show up frequently and predictably. Now, how did we get there? Well, by observing it in a lot of different contexts. But at first, it was just observing it in school children. And even though we weren't talking about motivation in commercial airline pilots or loggers or plantation owners, we were looking at children learning in the classroom and what sort of motivated them to do that, and using models to fit the behavior, the observations into those, or rather, using models to help explain and predict kind of what direction those behaviors would go in. There's no controlling variables there. There's no random samples there. This is basic research. You have a theoretical model. So there were two at the time. The behaviorist model that said that we behave based on feedback loops, and then the self-determination theory model suggesting that we behave or we make decisions based on freedom to do so in the a couple of other aspects, so like social relatedness, and then the feeling of being challenged but not too much. So basic research begins with a theory and then looks at available evidence through the lens of that theory to see if it fits. So it's like trying to see if observations have a model that can be fit in to help us better understand those observations. And that's very important research, and it's basic research, theory-driven, but it's not the same as hypothesis testing in applied research, where we ask a very specific question of a specific population. That's when all the controls are required. All right, so those two types of research are very important to differentiate. Basic research may sound poor when compared to the very structured and rigid applied research, but both are very important. You can't have applied research without basic research. A couple of other concepts that are introduced in Stanovich's book, it's the college sophomore problem, but I think college student problem more generally is appropriate. A lot of psychology research is conducted using college students because they're in our 100 and 500 student lecture halls. And a lot of times, not at my school, but at the schools that I've attended in the past, there was a requirement that psych majors had to participate in at least one or two experiments or studies. So if I was interested in studying self-determination theory, and all of my participants are college students, am I really getting a good look at how applicable self-determination theory is? Or am I only looking at Gen Z right now, for example? Or I'm only looking at people who have a comfortable enough socioeconomic status to afford the time and money to go to college, or who have the at-home support to attend college. There are a lot of demographical concerns if we're trying to study all of motivation or all of emotion or all of perception, only looking at one unique demographic. And so the argument there that what we study in college students doesn't apply to non-college students would be a generalizability problem. So a research finding is generalizable if it can apply beyond the sample or the population the sample is intended to represent. If it can apply beyond that. So if it's generalizable, it applies beyond the sample and the population represented by that sample. A study is ungeneralizable when that application can't be made. For example, do we have any reason to suspect that the biology of hair follicle growth, say, would be different for one group of people than another group of people? Well, possibly if you see some pretty extreme differences in hair composition, or maybe the lifespan of hair, genetic differences. We start looking at why different populations might have different hair follicle characteristics. So that's not a good example. What about, trying to think of a good, what about just perception of color? Do you think that a bunch of students at a regional HBCU might have a different ability to see colors in the color spectrum than a comparable sample of students at a state or at a public university in England or China? Do we think that there's different color spectrums available in the human visual spectral field? I can't imagine so. Wouldn't it be okay to test student sensation capacity and trust that it applies to a variety of um, different demographics and ethnicities and nationalities? We don't necessarily have to test every possible demographical difference when we're studying something like emotion. But there might be reason to suspect that self determination theory, for example, so a theory of motivation, may not apply to some groups. So, groups, autonomy is very important in self determination theory. Autonomy is the degree to which someone feels like they're choosing for themselves what they do, they're in control of their behaviors, of their actions. And the opposite of autonomy would be someone is controlling them. And so feeling like you're a pawn is one of the metaphors that's often used. Are there some social environments where that's okay, where people actually feel comfortable being told what to do? Um, you might make the case, this is wrong by the way, but you might make the case that collectivist cultures, where it's very important to not stand out or be different, that's sort of frowned upon, that collectivist cultures may find autonomy less important. When it's tested, however, in East Asian and South Asian cultures, autonomy is still an important factor in determining motivation and how intrinsic that motivation is or how internal that motivation is. But we might expect to find differences, but we could test those. So I hear a lot of students share that if a sample doesn't include everyone, it doesn't count. So if I were to take a representative sample of ASU students, then they would suggest that that sample, whatever I'm looking at motivation, wouldn't apply to a similar sample of students at a primarily white institution, such as Kennesaw State University, or a private school like Mercer University in Macon, that I would need to test it separately and at each of those locations. And perhaps, depending on the topic I'm studying, that might be important. But that's not an immediate reason to discount the results of a study. So you have to ask, is there any reason to suspect that a sample is not generalizable to a larger population or other populations that the sample wasn't geared towards? And have a good reason as to why, in order to reject it as to being ungeneralizable. So is there a problem with using college students? I think there would be if you wanted to study the use of social media, for example. So if I were to do a poll or do a detailed survey about social media values among college students, who right now are primarily Gen Z, I wouldn't expect those results to apply to a similar population or sample of Gen Xers or the forgotten generation. And so people much, much older, 3 times as old as Gen Zers. But if I was studying, I would have to think for a while to come up with another example. A lot of things in psychology would sort of change if we looked at extremely different age groups. So you'll have to wait on that sort of example. Let's move on. So, replicability is on this slide. So generalizability was the previous slide. A study is replicable if the same findings can be yielded by another researcher, provided they follow the same steps and gather a comparable sample. There's not a lot of studies that focus on replication. In other words, you would find the results of a study and say, I wonder if I can repeat the study and find the same thing. And if you repeat the study and don't find the same thing, and you feel like you followed the steps very carefully and there was no error on your part, then it challenges the generalizability of the first study. So does that mean that we can throw the results of the first study out? Well, Stanovich points out, and I agree here, that no, that doesn't mean that the original study was invalid. Let's just say, for example, that there's a study done of college students demonstrating that, and this was actually done, there's an implicit racism when evaluating the stature of football players. And so if the football players of similar stature have white skin versus black skin, the football player with black skin is going to be perceived as more dangerous and more threatening. And this was a famous study in APA, I want to say in 2016 or so, and I wrote a book chapter on it. You can look it up if you're interested. But there was a bunch of data over, I think, 7 different experiments demonstrating this implicit racism. No one was like going out of their way to say, because this person is black or because this person is white. They weren't using race to justify their evaluations. However, looking at a large sample of college students, there was this consistent effect that could only be explained by the race of these individual people. And I say football players because they took recruiting pictures, and the recruiting pictures came along with statistics about how much they could weigh, how much they weighed, or how much they could lift, how much they weighed, how far they could throw the ball, things like that, how fast they were. So they could control all of these and then look for evaluations made by these college students who were asked, how threatening does this person seem? So if that was done, I forget which college conducted that study, but say like that was done at one place, and it was replicated in Washington. Let's say it was done in Tennessee and then replicated in Washington, but the replicated results did not correspond. Like in Washington, they did not find, and this is hypothetical, I'm making this part up. If in Washington they didn't find the same results, does that mean we could throw away the Tennessee results? Well, no, it just means there's more to it than that. There's more to it than it applies broadly. There might be something happening in Tennessee, something that Tennessee represents, or that sample in Tennessee represents, that the sample in Washington does not represent. So there might be nuances there. So we don't throw away the results. We just say, uh-oh, there's evidently more to it than we thought. And I think that's an important point. Okay, the rest here are questions that I've designed for college students to answer. So if you're interested, you can stop at each one of those slides and try to answer the questions by applying scientific reasoning, as well as a grain of salt if it's generalizability or replicability or the artificiality problem. So take a look at those.